Good morning. March 4th? No, April 3rd. Yeah, it's April 3rd today. Yesterday was quite a weather show that we had. It was 0 degrees all day long and crazy winds, rain, snow in the morning, and more rain through the evening. And today, what do we have? 15 degrees at 10 o'clock in the morning right now. 15 plus, and it's supposed to be pretty much sunny. Crazy weather, I tell you. Right? But that's what they say. If you live in London and you don't like the weather, you gotta cross the street. Yeah, you never heard that one before. All right, enough small talk. Let's continue with the merit of things. All right, so we're going to continue from. This was the last slide that the other group got as per first part of the of week 12, which would be the the continuing of the topic. You're going to get that part in person this week. Is it today or tomorrow? So let's touch on the fire a little bit, and then security surveillance, and that is going to be it to close that triad or the trilogy of topics. Week 12 trilogy. All right. Fire. I mean, don't go into the crowd and scream fire, because you can actually get criminally charged for that if there is no fire. All right. Now, similarly to security systems, fire alarm systems have, main panel that can be interfaced with other panels or sub-panels or display units, display panels. It does have wiring, and it does have, fire alarm, have sensors or triggers, and it has annunciators, and of course has the communication capabilities with what? Well, monitoring station. Just as security alarms are not connected to the police stations, they're connected to the monitoring stations. These are private businesses who provide alarm monitoring. So just as the security alarms are not connected to police, the fire alarms are not connected to the fire department. Fire alarms are also, when it comes to communications, are connected to the same monitoring stations that the security alarms. It's just they're just being treated as fire alarms instead of security alarms. Sometimes it is possible to connect fire alarm like a dry contact that follows the state. So if, for example, there's a contact or program point that is triggered based on the condition. So if the condition is alarm, that relay is going to close the switch, and it can be connected to one of the zones of the security alarm. And that zone can be programmed to be a 24/7 monitored zone, like a fire zone. So it doesn't matter if the system is armed or disarmed. If that point triggers, then it's the system goes into alarm mode, and for the fire alarm it just makes sense. Then some of that output program, instead of the whole thing being connected through its smart devices with the monitoring station, it could be triggering one of the points of the security alarm, and the security alarm is going to send the information, is going to communicate with the monitoring station. Now, is it permittable or not permittable? That is that all those the security and the fire bylaws, they go usually by the city bylaws, right? So, in some cases, it might be permittable to use that kind of a system, and maybe in some cases, in some cities, no, somebody might decide, no, you need a separate communication system from the fire alarm. And so always, whenever you're installing any of those systems, like everything else, especially this, it has to be verified. Things have to be verified against the city bylaws and otherwise codes that apply locally or nationally. Okay? All right, so let's take a look at some of the fire alarm, let's say triggers. With the fire alarm, triggers are sort of simple when it comes to classifications. However, they do have some differences when you are splitting some of the branches of the types of the triggers. For example, the triggers would be smoke detectors, such as these, heat detectors, such as these, yeah, smoke detectors, heat detectors, and manual triggers, popularly called pull stations. Now, of course, where the branch is splitting itself would be there could be different types of pull stations constructed in a little bit different way. Or, for example, when you have smoke detectors, the smoke detectors could be ceiling mountable smoke detectors, or they could be, for example, smoke detectors that are mounted inside the air ducts. So that type of thing, and of course the heat detectors, they can have different shapes, and for the most part they work the same way. Some of them could be just a simple heat detector, and sometimes you got a heat detector with the test button to press, which is a great idea to have, because when you do the annual verification, and fire alarms have to be annually verified, so it's a business. Fire alarm system, when it goes to as far as work with the fire alarms, where we are right now, the fire alarm technicians do not install the fire alarms, as opposed to the security alarm techs would be installing the security alarms. Fire alarms have to comply with electrical code and with the fire code, which they're pretty close. In some cases they overlap, but fire code applies, which is just as thick as the electrical code as far as the book is concerned. You need a special license to work on fire alarms. So if the alarm tech, fire alarm, before we used to do that, let's say, well, 15, 20 years ago, something like that, we technicians were able to install, fire technician would be able to install the alarm system. Now, an electrical, someone who holds the electrical license needs to do the installation as far as running the pipes, because the wiring for the alarm system, fire alarm system, is slightly different. It's more strict than wiring for the security alarm. So a lot of the activities are similar to the electrical business, such as pipe bending, using flexible armor, like BX type of a wire, and so on. So an electrician has to do that. Now, a fire alarm tech can verify if the installation is done correctly, but they can't install as it is now. The jobs that are involved would be design of the fire alarm systems, making sure that the building is properly equipped with the fire alarm. So, do we have a smoke detector in every enclosed room? Do we have heat detectors where they're supposed to be? Do we have pull stations placed according to the fire code? Do we have annunciators at the proper places? Do we have the main panel intact? And so on. And the fire alarm tech would be doing the annual verification, which is basically it involves two people, right? It involves the fire alarm technician with the fire license, and somebody who's called a resetter. That could be anybody. Could be a girlfriend, could be a wife, could be a boyfriend, could be someone who just, not necessarily qualified as a technician, because their job is to stand by the panel while the techie goes and verifies every single device. So that's why it is a good idea to have those test buttons on the devices, so you can press the heat detector test button and send a signal to the main panel, so the person who is hired as a resetter for the day can read on the display what is it that showed up when the tech has triggered that. And then once that, because the alarm system is being put in the test mode and monitoring station is notified and so on. So then when every single device is triggered, including the pull stations and smoke detectors, and maybe blowing some artificial smoke into the air ducts just to trigger some of the air duct smoke detectors. And the resetter is going to read what appeared on the main panel, what has been triggered, and then press the reset button for the next device to be triggered. So that's why we call them resetters. So that's also fire alarm tech position is taking care of fire extinguishers, and there are certain type of rules when it comes to fire extinguishers. Fire extinguishers have to be periodically serviced, which means if there's that time of the year that the fire extinguishers have to be pulled off the site, taken to the facility, and tested, verified, maybe refilled, and pressure test performed, and so on, then, you can't leave the client without fire extinguishers. So you put out the loaner fire extinguishers all over the place. And when that client's, all the fire extinguishers have been serviced, then you just drive back again and replace the loaners with the client's fire extinguishers. It also involves training. So, for example, the fire tech would be training the people, the client, on how to use the fire extinguisher. Because what good is a fire extinguisher if you don't know how to use it? Average human being can figure it out when there is no stress of the moment. But if there's a fire, there's no time to figure things out, because your mind is spinning, your hands are shaking, you're on the verge of panic depending on how used you are to stressful situations of that type. So the motions have to be automatic. So training how to use the fire extinguishers is part of the fire technician, and training on how to inspect the fire extinguishers, because when it comes to fire extinguishers, every fire extinguisher, I use that term a lot today, has to be monthly inspected by the client. And there is going to be a tag with some of the calendar-like type of a table, and on which whoever inspects it once per month is going to write down the date that the fire extinguisher was inspected and have their little initials put in there. That has to be done monthly, and it is the law. But once a year, I think it was once a year in where we are right now. The fire extinguisher has to be pulled off, or was it once a year, maybe sometimes once 3 years. It depends on the rules of the law of the land. I think it's don't quote me on 1 or 2, 3 years. Have to check it with the fire code. Then those extinguishers have to be pulled off the shelf, serviced in the facility, and sometimes some of them, I think it's like 6 years. They have to be completely emptied and subjected to a pressure test. So use kind of a mount, a nozzle, special kind of nozzle on top of the bottle. What is called the bottle, fire extinguisher bottle. Submerge that in a water tank, so if things blow up, nobody's gonna get injured, and high pressure is being introduced to that, and see if anything happens to it. Right? So that's as far as the fire extinguishers, and then of course the technician would train the people how to inspect the fire. Yeah, I just said that a couple minutes ago. However, I'm going to tell you what evolved just as a regular client, what's involved in inspecting a fire extinguisher. Well, you have to first you just do the overall kind of a once-over look to see if there's any obvious damage that you can see. Maybe the hose is damaged, maybe the safety pin is not secured, or maybe it's missing. Is the trigger maybe bent out of shape or something like that? Are there any rust signs, corrosion signs? Is the pressure proper? Inside it has to, the pressure gauge is quite obviously made so you can, it has to be in the green zone. The needle, the indicator, the deflecting needle has to be within the green zone, which is good. If it's too much pressure, it's not good one way, and if it's not enough pressure, that leads maybe the fire extinguisher was fired. Then the pressure is going to be below normal. Then that kind of stuff has to be overly checked, right? Then that's not the end, because a lot of people think that this is it. And if some people say no, because some firemen told us, no, a fireman would not tell you just to stop at that stage. If a fire person would not legally tell you to just do the visual inspection and leave it as that. They would not tell you, they would never tell you that. There's next stage of inspecting a fire extinguisher monthly, especially those dry powdered, those ABC powder, and it's the powder B, powder C. It's for different type of fires and so on. So quite often there's those 3 types of powder. I'm not going to get into what's in those powders, but well, it's kind of yellow. When it blows up on you, everything is covered with yellow powder. Well, the problem with that is that here's the problem. Here's the challenge. The powder solidifies if it's staying in one position. So if for a whole year or 2, somebody just takes a look at that fire extinguisher just to see if there's any physical obvious damage, and then, yeah, okay, good, put initial, put the date, and that's it, I'm good. After about a year and a half or 2 years, or maybe even less, that powder can solidify on the bottom of the bottle. And if it solidifies, what happens? Well, you get to use the fire extinguisher and just some kind of air blows out of it and there's no powder because it's solidified. So the proper way of inspecting, at the end, you should pick it up, turn it upside down, shake it, so the powder gets a chance to kind of be loosened up a little, and put it back. That's the final stage of the fire extinguisher inspection. Now, some people get the bright idea of hitting the extinguisher with a rubber mallet because I'm so clever, I'm going to make sure that the powder gets loose by hitting that bottle with the rubber mallet. Don't do that, okay? Because once you turn the extinguisher upside down, all the powder collects, well, it shifts towards the nozzle of the fire extinguisher. And the nozzle has some mechanical parts which can be plugged up by hitting the hole, introducing the vibrations with the rubber mallet. That powder can get into places that it shouldn't be and can clog up the valve. All right, so don't do that. Just turn it upside down and shake it. It is the duty of every client to do that. So that's as far as the fire extinguishers. It's a business, residual income, annual business. Every commercial facility has to have a fire alarm installed. It has to be fire protected, and the fire alarm has to be periodically verified. All right. So what is interfaced with the fire alarm panels? Well, there could be a main panel that has zones, just like security alarm does, and it would have maybe some secondary panels, like for example this here, remote annunciator. So the building could be relatively big, and if there's fire alarm goes on, you don't want people to run to the other side of the building to see where possibly could the fire be, if it's not obvious. Right? So some of the remote annunciators can be installed, so you could tell what's going on, whether it's the trouble, and we'll talk about what trouble is, or is it alarm condition. There could be a secondary panel feeding the main panel, and there could be some, what does this one say, smart relay module, or relay module, so contact points that send signal to other places, depending on what's interfaced with that alarm system. All right, so as far as the zone construction, zone anatomy, if you could say that. Remember when we had the security alarms, we would have a zone. Where's my pen? Here it is. You would have a zone terminal here, and you would have a sensor, whatever the sensor would be, and this thing would be placed in series. So for the most part, by default, the security alarm is looking for a closed loop to be at ease, and when you trigger the alarm, the sensor just opens. Okay, by default. But of course, we could have different type of zones. We could have a fire zone in the zone programmed as a fire zone. Then it works just like the alarm zone, which I'm going to show you. Or there could be something that's called EOL, end of line resistor. And in that case, the alarm zone can be looking for that specific resistance at the end of the line in order to either be at ease or be at ease, and you could have a parallel, normally closed loop and end-of-line resistor, and then you could tell in the programming that this is two zones. These are two zones. So that's how you double the amount of zones, which I, in the previous lesson I said, I am not too fond of that. I never used that, because that's like too complex, too complicated, and I'm not sure it's a good idea to put it against the test of time. When there's a wear and tear on the system and things like that. I just, anyways. So the fire alarm zone is a little bit different. All the sensors, as opposed to security alarm, all the sensors are normally open. So the system doesn't even see them until they trigger. So this could be a pull station, it could be a heat detector, it could be a smoke detector, anything that has to do with the fire. Or it could be a part of a relay from another system. It's normally open. What is the zone looking for sure, is going to be the end-of-line resistor. Now, I just put the value of 47 kilo because it's a common value of the end-of-line resistor. However, you should verify with the brand and the manufacturer and the manual of the specific alarm that you are installing, because there's not just one type of fire. There are different brands. They compete. All right. Excuse me. So excuse me. It's the season. Still lingering with some of the stuff, whatever happened. Anyways, so the security alarm, so for fire alarm, is looking for the end-of-line resistor. And the end-of-line resistor has to be at the end of line. So when you're running a wire, and if you're connecting more than one sensor to that loop, to that zone, that end-of-line resistor has to be at the end of, physically at the end of line. Now, if you connected that here, right at the, would the system work? Yes, but it will not work properly. What do I mean by that? The purpose of the end-of-line resistor is to make sure, because all of those sensors are open, you have to have some sort of way to verify that the wire that goes from beginning to the end is not broken anywhere. Because if it were, and if there were no end-of-line resistor, you would never know if the line is broken somewhere. And there could be some workers working in the ceiling, doing something, moving wires, breaking wires. There could be some rodents chewing through some of the wires. Who knows? Squirrels, right? So that's why we need to have the end-of-line resistor at the end of the line. If the end-of-line resistor, and I've seen improperly installed alarm systems when the end-of-line resistor was here, right here, and the panel would not show any troubles, right? Except you wouldn't know if the whole thing is intact. So at the end of line, put the end of line resistor, and if there is a break in line, the system will let you know by producing annoying beeps at the panel, and there will be some sort of a light indicator or a displayed message that the system is in trouble. A trouble condition is not an alarm condition. A trouble condition means is that there is something wrong with the alarm physically or anywhere, any way, like software. There's something wrong with the system that makes the system not, maybe it's not 100% efficient at the moment. Like, for example, a broken line. So then usually that goes with the phone number to call. And there will be the service company that would send a technician. Now, how is it that the system triggers? Of course, if there is a trigger, then the switch is closed, and what the zone is going to see is pretty much very low resistance, close to 0 ohms, and it's going to go into alarm condition. So the sensors are normally open, as opposed to the usual security alarm normally closed. For the fire alarm, sensors, what do we have? We have heat detectors, smoke detectors, and manual detectors. Sensors, heat sensors, smoke sensors, and manual triggers, such as pull stations. Also could be the kitchen fire suppression systems, which is completely a different animal altogether. These will be the nozzles suspended over a hot plate in the professional kitchen, commercial kitchen. So if there's a fire, there's a heat detector right above the hot plate, or this otherwise heat source for cooking. And if there's a fire, then that heat detector breaks the line, which is spring-loaded, which is preventing the big fire extinguisher bottle, huge bottle, from releasing its contents onto the hot plate. So that thing's being released, the contents are being sprayed, and then followed by cold water, so the system does not reignite. There's a whole system. We do have one upstairs in 1023, T1023. We do have one of those demo. So sometimes maybe we can take a trip there and just take a look at that. How it works. It involves small to medium system, a kitchen system, which would involve one bottle, one hot plate. It would be 2 people most of the day. One experienced technician could do it in one day, but he will be very tired after that. So usually it takes 2 people one day to install that. Now, so sensors will be heat, smoke, manual, pull station, annunciators, bell, siren, and strobe, and there is a certain amount of noise level that this annunciator has to produce to be noticeable, and it has to be accompanied with the strobe, and of course, a PA system has to be in working condition for the announcements to be made, whether it's a false alarm, whether it's this is a fire, get out of the building, or please come back, and whatever. The PA system has to be in working condition, and we have done the PA system installation lab, right? Right. Excuse me. All right. Now, controls. How do we control the fire alarm system? Well, through the fire alarm panel. Of course, the programming can be done through laptop or outside IP, through the IP Internet Protocol remote access systems. So that's as far as the control. Now, electrical code in effect, fire code in effect, and licensing involved. We do have fire education in our college. If this is something you're interested in, talk to me, talk to Mr. Riekers. We'll point you in the right direction. But there's some additional courses you would have to take. What is the fire alarm interface with? Well, security alarms, monitoring with sprinklers. Right? That's another animal that is introduced with the fire alarms. PA systems, kitchen fire suppression, and other things. All right. Wiring or cabling. It's a fire. The cabling has to be fire rated, not just any kind of well, of course, there's a fire rules and regulations as far as any kind of cabling that is being installed, so-called free air in the ceiling. If the wiring is in the pipes, conduits, then the fire regulations do not apply as much. But when the wiring is run free air, suspended over J-hooks, in the ceiling space, and so on, depending whether it's a cold L return plenum or not. Maybe this would be a good idea for me to explain what a cold air return plenum is. So just give me a sec here. Now, as far as the wire, the cabling, it is Z kind of cables, but it has a little bit different color coding, and some of them have to actually be armored cables, depending on the situation, depending on type of facility that you are. Now, as far as what is called a return plenum and what does that have to do with fire regulations? All right, so here we have a floor of a room. Over here we have the ceiling tiles. And over here we have the true ceiling. And over here is the floor to the next floor. So here is you. Here are the ceiling tiles. Here is the true ceiling, which is the floor of the next floor. And here would be those suspension rods that are holding the frame for the ceiling tiles, for the suspended ceiling, or sometimes called a dropped ceiling. All right, so that's as far as introductions. Now, as far as the air circulation, the air has to be circulated, it has to be pushed into this room, and it has to be sucked out of this room, and the whole thing has to run like a circle of life. Well, there are two ways of doing it. One is the closed system, so you have the vents, let's say, let me change the color a little bit. Here we have the push vent that pushes the air, and that thing is directly connected to the furnace. And this is the supply air vent. Now, in order for the circulation to happen, you're going to have some sort of a grid in the wall or in the ceiling. Well, let's draw this one in the wall. And that is also by a pipe connected to the furnace. So from the furnace, the air just being circulated all around, and everybody happy. Okay. Now, this space between the ceiling tiles or the suspended ceiling and the true ceiling, that's called plenum. Plenum. Okay, it is called plenum. Now, the plenum could be a cold air return plenum or not cold air return plenum. This, what I drew right now, is a not cold air return plenum, which means the wiring that is inside that plenum doesn't have to be as much fire rated as if it were cold air return plenum. And the wiring is cheaper, and the rating of that is FT4. FT4. FT4 cable. And FT4 cable as opposed to FT6. This is fire. Fire rated. This is a fire rated cable, and this is not a fire rated cable. What makes it a fire rated? The jacketing. So if you have a data wire, that's FT6, it's fire rated, which means the jacket, the insulation, is not going to burn as quick as FT4 would, which goes together with the release of the toxic fumes, because when the wires burn, they release toxic fumes. So the FT6 can take a lot more heat before it starts burning than FT4. In this case, if it's not cold air return plenum, then you can run FT4 cable. If it's a cold air return, you don't have this closed systems system for the return. The supply vents are the same, but the return is solved a little bit different. What you're going to have, let me change the color again for maybe, let's get kind of like a green here. Okay, why not? You don't have that for the cold air return plenum. You would have a big cavity somewhere in the ceiling space. You would have a big intake cavity, so the air just being sucked into it, and that is physically connected to the furnace to make the air circulate. In order for the air to be circulated, then there has to be a break in the ceiling somewhere, and just a grid. You're going to see just a grid installed. If you shine a flashlight through that grid, you're going to see the true ceiling here. Excuse me. So that is called cold air return plenum, because that negative pressure created by the suction of the vent or fan creates negative pressure through these grids. So the air kind of gets slowly sucked in and goes right in there and just goes back to the furnace. But the cold air return plenum can cover more than one room. So there could be 3-4 rooms where the ceiling space, where the plenum is basically wide open. And that one huge common intake in the plenum will just suck the air from all the rooms, but there's one big one. So the cold air is being returned through the plenum into those intakes that are somewhere in the ceiling, huge openings. That's why it's called cold air return plenum. Now, in this case, we need FT6, right? Fire-rated jacketing that doesn't burn as much. So for not cold air return plenum, FT4 is fine, but for cold air return plenum, FT6 has to be installed, and it's just a different type of jacketing. It has nothing to do with the specification of the cable, with the twist rate or not twist rate, or whatever the specs that the cable needs to have. Nothing to do with that. It's the jacketing that is being used to enclose that cable, fire rated or not. And the reason for the FT6 to have to be installed, that has to be installed in the cold air return plenum, is because if there were FT4, then if there's a fire in one room, that could cause the wires to burn, and the toxic fumes can spread to the other rooms, including to the furnace and the whole facility. So that's why FT4. Talking about free air wiring in pipes, especially EMT, which is electrical metallic tubing for the wires, then you can install FT4 or FT6 because that wire is protected by the metal enclosure. But if it's a free air wiring, then that applies, cold air return plenum or not. And inspectors do have, the inspectors do have sixth sense when it comes to detecting that type of thing. The inspector can just give one quick look at the wiring that you have installed, the data wires, for example, and he's going to say, yep, nope, you gotta replace that wire. It's not like you can't use that. That wire has to be pulled out at your cost. And then you still have obligations, contract obligations to the client to have the proper thing. Now, why would some people be tempted to install FT4 instead of FT6? Well, this is cheaper, about 3 times as cheaper. But first, it will be noticed by the inspector. And if it's not noticed, maybe it's a retrofit that you're doing that you can just bypass the inspection. Well, not bypass, but it's not going to be inspected. But the next time some inspector goes in to take a look at something else, they're going to notice that, and you're going to have to come back and correct that. Or even worse, if something happens and somebody gets injured as a result of fire or something like that, you're going to have a whole bunch of inspectors trying to find anything that's possible that they can find, and well, put it against people who did something incorrect. So that's as far as the fire alarms. That goes also with the security alarms. That goes also with the data installation. So it's all connected, kind of thing, right? You know what? As far as the security surveillance, we're going to touch on maybe next week on that. Yeah, why not? Actually, it works pretty well. Good or well? So yeah, we're gonna finish on at this point right now with at this. Yeah, we're gonna finish with this slide, and we're going to have one more week 13 of theory content. Going to tell you more about we're going to touch up on surveillance, which is the security cameras, the basics of that, how things are being installed, and I'm going to give you certain type of installation concepts. I know why we've done that, but I'm going to give you that from a little bit different angle. You will see. Cool, but this is it for today. Thank you for your attention. We still have 9 people down here. Oh, diehards, stick to the content. There we go. Yeah. Wonder if you see it or not. Cool. That's it for today. Thank you so much. Have a great rest of the week. Bye-bye.